In this lecture, let's learn about interrupt priority and configuration. In this section, we are going to learn what is priority value, different programmable priority levels. We are going to explore priority registers for interrupts and priority registers for system exceptions. And also we are going to understand preempt priority and sub-priority. First, let's understand what exactly is a priority. Priority means urgency. Priority value is a measure of urgency. The priority value decides how urgent from others. Let's take an example. Let's say you have two peripherals, ADC and timer, and let's say the priority value of ADC peripheral is 5 and priority value of timer peripheral is 4. In this case, timer peripheral priority value is lesser than the priority value of ADC. Hence, timer interrupt is more urgent than ADC interrupt. What we say is timer priority is higher than ADC priority. That means in ARM Cortex-MX processor, lesser the priority value, higher the priority, that is higher the urgency. If both interrupts hit the NVIC at the same time, NVIC allows timer interrupt first. Timer ISR will be executed first by the processor. I hope you get the idea behind priority value and priority. Sometimes we use the term priority synonymous with the word priority value. So instead of saying priority value of IRQ0 is 4, we just say priority of IRQ0 is 4. I hope you can notice that usage. The takeaway from this slide is very important. For ARM Cortex-MX processor, lesser the priority value, higher the priority. Let's understand different priority levels. By the way, priority values are also called as priority levels. How many different priority levels or priority values are there in ARM Cortex-MX processor? You should know this before you configure any interrupt for any priority value or priority level. The answer is it depends on the interrupt priority register implementation by the microcontroller vendors. For example, if you take STM32F4X microcontroller, it has 16 different priority levels or values. If you take a microcontroller TM4C123GX from Texas Instruments, it has 8 different priority levels. Priority levels or priority values are vendor specific. Let's explore the interrupt priority register of the ARM Cortex-MX processor because this is a place where you configure the priority for interrupts. Interrupt priority register is part of NVIC register set. Here you can see that we have 60 interrupt priority registers to cover all 240 IRQs. By using these registers, you can configure priority levels for IRQs only, remember that. You cannot use these registers to configure priority for system exceptions. Let's explore this interrupt priority registers. You can get the details from the generic user guide. So I have taken this from the generic user guide. As I said, there are 60 interrupt priority registers from IPR0 to IPR59. And by using each priority register, you can configure priority for 4 IRQs. This is a 32-bit register. And by using this register, you can configure priority for 4 IRQs. 60 into 4, which covers all 240 IRQs. Let's see the real implementation of interrupt priority register. As I said, priority register is of 32 bits. And that 32-bit register is divided into 4 sections, and each section is of 8 bits. Each 8-bit section is used to control or set the priority for each IRQs. For example, in the IPR0 register, the first 8 bits will be used to configure the priority for IRQ0, then IRQ1, 2, 3, like that. This is the real implementation of these 8 bits. Out of these 8 bits, all bits are not implemented, remember that. Only few bits are implemented. For example, in this case, the MCU vendor may implement just 3 bits in this register, and the rest of the bits are not implemented. That's how the real implementation is. That depends on the microcontroller vendor. For example, the microcontroller vendor X may implement only 3 bits, and the microcontroller Y may implement 4 bits. If only 3 bits are implemented, then there are 8 priority levels like this. So these are the different priority levels: 0, 0, 2, 0 cross is 0. If there is any IRQ with this priority value, then it will be of highest priority interrupt. And if there is any priority with this priority value, then it will be a lowest priority interrupt, like that. If 4 bits are implemented, then there are 16 priority levels. In our STM32 microcontroller, the manufacturer implements 4 bits. That's why in our microcontroller, we have 16 priority levels. If you want to configure the priority for system exceptions, then you should be looking at system control block, not into the NVIC registers. In the system control block, you have registers called system handler priority registers. These registers, system handler priority registers. By using these registers, you can configure the priority for system exceptions. With that note, I would like to end this lecture, and in the next lecture, let's do some exercises. And after that, I will explain the preempt priority and sub priority. I'll see you in the next lecture.